Hello everyone. In this video, we will compute the percentile for the present value random variable for the life annuities. As usual, we will start with the whole life continuous annuity. We have this expression for y. And we can expect that y is an increasing function of tx. And this is a demonstration and illustration for the graph y versus tx. Suppose we want to get the probability that y is less than a particular value, say eta. This is equivalent in finding the probability that tx is less than a particular value. Let p be the 100 times p percentile for y. And therefore, we have p equals to the CDF of y at eta. That is the probability that y is less than or equals to eta. Express y in terms of tx with using this expression. Solving for tx within the bracket here, and we get the probability statement that this probability y less than or equals to eta is equivalent to the probability that tx is less than or equals to this expression. And this corresponds to the CDF of tx at this particular value. And this also equals p. That is, if we want to get the 100 times p percentile of y, this is equivalent in finding the 100 times p percentile of tx. All right, let's take a look at some examples. For a continuous whole life annuity of 1:2 to an individual at age 25, given that the mortality follows the Morpheus law, omega 120, loss of interest 0.08, calculate the 80th percentile of this annuity. Let's take a look at the solution. To get the 80th percentile of y is equivalent in getting the 80th percentile of t25. The CDF of t25 equals 0.8, and we want to get the value for t. The Morpheus law, omega 120. We have TQ25 equals to this expression. Solving for t, we get t equals 76. And this is the 80th percentile of t25. To get the 80th percentile of y, so we can assume that the individual dies at this time point. The value for y is a bar angle t, and t is 76. With delta equals 0.08, we can get a bar angle 76. And upon calculation, we get 12.4714. And this is the 80th percentile for this annuity. Another example, a whole life annuity deal of 100 issued to an individual at age 45. Mu 0.03, I is 0.06. Calculate the 35th percentile of y. All right, 35th percentile of y is equivalent in getting the 35th percentile of K45. And here we are having a discrete annuity deal here. So we are dealing with K instead of T. All right, assume for the continuous case, we still work for T45. So we have the CDF for T45, set it equals to 0.35, the 35th percentile. Constant force of mortality, 0.03. So we have this expression for TQ45. Solving for T, we get T equals 14.3594. You can assume the individual dies at this time point and then calculate the corresponding value for Y in terms of the annuity due. Instead, you can get the value for K45. And here, this value for T corresponds to K45 equals 14. And you can verify this using the definition of percentile. 14Q45, 0.3430, and 15Q45, 0.3625. So the 35th percentile for K45 is K45 equals 14. All right, the expression for Y, this is an annuity due. So we have 100, the annuity payment 100, and then A double dot, angle K plus 1, and K is 14. Upon calculation, we get the answer, 1029.5. For the temporary annuity, we have the maximum. The maximum for Y is A bar angle N. All right, to get the 100 times Pth percentile of Y, if P is greater than or equals NQX, then the value for Y is the maximum, A bar angle N. Let's take a look at a relevant example. A 20-year temporary annuity payment of 1. Current age, the individual is at age 35. Mu is 0.03 and delta 0.08. Calculate the median of Y. That is the 50th percentile. The median of Y is equivalent to finding the median of T35. This one is straightforward. Constant force of mortality, we solve for T, and we get T equals 23.1049. But this is a 20-year temporary annuity. So the corresponding value for Y is the maximum, A bar angle N, in this case, A bar angle 20. Or if you calculate 20Q35, you get 0.4512. So that is starting from the 45th or 41.12 percentile to 100 percentile, the value for Y is A bar angle 20. And upon calculation, the value is 9.9763. And then for deferred annuity and certain and life annuity. For deferred annuity, we have this CDF for Y. A probability mass at Y equals 0, NQX. That is, for the 100 times Pth percentile of Y, if P is less than or equals NQX, then Y is 0. For certain and life annuity, the minimum value for y is A by angle n with a probability mass nqx. Therefore, if P is less than or equals nqx, the 100 times pth percentile of y is A by angle n. All right, let's take a look at an example. Here we have a continuous 10-year certain and life annuity immediate. Annuity payment $1 issued to an individual at age 36. Mortality follows the standard ultimate life table here. I is 0.04. Calculate the 10th percentile of y. All right, this is equivalent to finding the 10th percentile of K36. Assume for the continuous case. So we want to solve for the value for t. L36, we have the numbers. And then solving for L36 plus t, we get 89,566. And according to the table, this corresponds to the age between 71 and 72. Assume the individual dies between these two ages, and this corresponds to the value K36 equals 35. When K36 equals 35, then we can get the value for y, and this value corresponds to the 10th percentile of y. This is an annuity immediate, so the expression for y is A angle K, and K is 35. And we get the answer, 18.6646. Another example. Here we have a 15-year deferred annuity deal of one issued to an individual at age 32. Mortality follows the Morpheus law, omega 110. Interest rate 4.5%, 0.045. Calculate the median of y. All right, this is equivalent in calculating the median of K32. Let's solve for the random variable for T32, assume continuous case. Omega 110. Under the Morpheus law, so TQ32, we have this expression, set it equals to 0.5, solving for T, we get T equals 39. So assume the individual dies at this time point. And here we get 39Q32 is exactly equals to 0.5. In terms of K32, this corresponds to the probability that K32 is less than or equals 38. And therefore, this corresponds to the value K32 equals 38. Plug this in to get the value for y. The expression for y, this is a 50-year deferred annuity deal. So we have A double dot angle K plus 1 minus A double dot angle 15. And here K is 38. Upon calculation, we get the answer 7.8272. All right, that's it for today's video. Thank you for watching and see you in the next video.